and then we'll get to something else. View full screen. Okay, very quickly I'm going to run down this quiz. So we'll have it. Quiz 11. Okay, on number 1, a sample of gas is heated. The volume of the gas would be expected to what? So we know volume is directly proportional to temperature, Charles' law. So increasing temperature produces an increasing volume. Right there. A sample of gas is confined to a cylinder. And you have pressure 1 at volume 1, and the cylinder is pushed down so that you have P2 now at a different volume, V2. So we decreased volume. What happens to pressure? Does it go up? Mm-hmm. Yeah. So this is a pressure proportional to 1 over V, Boyle's law. Right there. And so that's an inverse relationship. As a matter of fact, it's the only inverse relationship in the empirical gas laws. That's when you're comparing just pairs of variables. Which of the following is not an STP condition? That, of course, is 0 degrees Fahrenheit. What is it? Celsius, right. So the standards you want to keep in mind are based on 1 mole values. It still gives 22 gives the R value but you have to change mass and volume. Okay, P, V, N, and T at STP values are 1 atmosphere, 22.4 liters if you're working with 1.0 mole, and 0 degrees Celsius or 273 Kelvin. Notice Kelvin, listen to me. Notice Kelvin doesn't have a little circle at the top of it. It's a mathematically derived value extrapolated in some graphs, and doesn't have degrees. However, the spacings, so to speak, of the Kelvin scale are identical to the spacings in the Celsius scale. So, for whatever that's worth. Okay, 1 mole, any gas at STP equals a volume, molar volume, equal to, as we've already noted several times today, 22.4 liters. C choice. Now, in number 5, I'll try to get it all on one page here, is C choice, but I gave you a decomp equation. KCl03 is a solid when heated strongly will decompose into salt, KCl, and 3O2 gas. 1 mole, given 1 mole of KCl03 at STP conditions, how much O3 would you obtain? Well, you can approach this problem a couple of ways. Okay, 2 is to 1 as 3 is to x, all for x, and it's 3 halves of the Vm, molar volume, and that would be 3 halves of 22.4 liters, and 33.6. Or you could look at the equation. Now, a lot of people haven't heard this. What is the given? What is the known in this equation? KClO3. If you convert the known item to a 1 coefficient, the unknown will have the appropriate coefficient, whether it's a fraction or not. You multiply that by the standard. So if I converted this equation so that the KClO3 has a coefficient of 1, how would I do that? Divide through by 2. Yes? Everybody good? Okay, so what happens is I have KClO3 goes to KCl plus 3/2 O2 in the gas. Well, I got 3/2 moles. If it's at STP, how do I get the moles based on the standard mole value? It's 3/2 of 22.4.